Okay, good morning, everyone. Today, uh, as I mentioned last time, we can start Bayes' theorem. This is a extended version, or I would say most common way to use conditional probability. This is based on conditional probability. Okay, you remember last time, given something, we found a probability. So Bayes' theorem develop on top of that. So same idea here. This is the conditional probability, but Bayes' theorem we talked about. If we have a if we have a particular event in our sample space, and we need to find what are the probabilities of partitions spaces. Okay, last time we talked, we have a partition space, something like AIs. So on top of that, we have an event. So we find the probability of that event. Right now, if we have an event. On top of that, we have some partitions. Okay, same thing, but in different way. Okay, so using this, we can find like second part, what is the probability of the second partition given that particular event, something like that, or everything AIs, or particular one AI, A1, A2, something like that. Okay, so same idea, same conditional probability. The difference is okay, I'll show you at that point. In statistics, if we consider statisticians, especially there are two types of statisticians. One type is frequentist, the other type is Bayesians. Okay, so those are the two major categories in statistics. Bayesians, like, they do something using Bayesian ideas. They use, you can find the name, we call prior probability, posterior probability. I'll tell you what are those, but they use that. Frequentists, they don't use that, but sometimes they mixed. It's like they like something like this. Frequentist and Bayesians, they are like this. Our normal Venn diagram. This is Bayesians, and this is frequentist, something like that. They have a common area as well. Okay, sometimes frequentist used Bayesian ideas, especially this one. Okay, to overcome some problems. They use frequentist ideas to overcome some problems. Okay, anyway, right now we have to learn this Bayes theorem. This is really important. Okay, uh, first check this one. Probability of AJ given B. Okay, so you know how to expand that using conditional probability. The idea, probability of Aij intersect B divided by probability of B. Okay, so last section, I mean last slide, you learn something like this, law of total probability, right? You can replace that denominator using this PB summation part. Okay, so that's what they have done here. So AJ mean it's a particular I mean particular value, let's say A1. Okay, but I mentioned here everything from 1 to, you can see in the denominator, summation from I equal 1 to K. So i's we consider from 1 to K, from 1 up to K. Clear? But J mentioned specific one, like 2, 3. Clear? Okay. You will understand this more when we are doing examples. I think we have 2 examples, so you will understand that. Okay, so don't confuse it, i's and j's. Okay, J mean just what value? Yes.
Sorry to interrupt you, but in the last slide, can you go on the previous slide, like for total probability?
Yeah.
Yes. Perfect. So here we have written the formula P of B, right?
Yes.
So there's a formula known like P of A given B. So the
Yes.
formula would be P A intersection B upon P of B, right?
Yes, yes.
So P of A intersection B will be the multiply of A given B by P of B, right?
Sorry, I didn't get you.
P of A intersection B will be equals to P of A given B dot P of B, right?
Oh, yes, this one. Mention here
Uh,
this one, right?
yes. So here, why there will not be P of B intersection AI? P of equals to P of B intersection B
Oh,
AI.
this is law of total probability. This is for probability of this event, this total event. Don't mistake this one. See, this is the conditional probability. Okay, once you write probability of A given B equals probability of A intersect B, sorry for that line, divide by probability of B. Clear? Once you cross multiply this, you can get this one.
Yes.
Okay? So this is, we call multiplication rule, but this is still conditional probability. But this one is different. It is total probability. This is the law of total probability. How we get the total probability. I mean, how we get the probability of that particular event if we have a mutually exclusive events. Clear? Don't confuse with that.
So in the total probability, what are the mutually exclusive event? It will be AIs.
Yeah, AIs are the mutually exclusive event.
Okay, okay, okay.
Clear? Do you remember
Yes,
that?
thank you.
Yeah, I showed you last time. I mean, we have this partitions. Oh, sorry, whatever. If we have this kind of partitions, our B, it defined on top of this, something like that. Okay.
Okay, so B itself represents the intersection between AIs, right?
Yes,
The
yes,
common part.
yes, yes.
Oh, okay, 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 okay. Thank
Okay.
you.
Okay. So I was there. So here, simply we plug the total probability for the denominator. Check the numerator. It is what? It came from simply, it came from, it is this, right? It is again, what? This part, right? Without summation. So it is also some kind of total probability. Not total, I cannot say total because there is no summation, but this is how it works. Okay, remember like this. Just consider the first equation. If you need to find a particular probability, I mean, let's say A1, one particular, what it's called, one particular sub event, given event, we can write it like this. I'll show you this. Okay, let me. So if we need to find, okay, if we need to find probability of given event, okay, let's say number one, okay, given probability of one, I don't know why they draw these lines. Okay, this is, let me try it again. Number one given number two. This 1, 2 mean a general event, okay? Number one, it has partitions, okay? It has partitions. Number one has partitions. So I need particular this event, okay? This is an event, okay? Let's say T, simple T, okay? Let's say simple T. So simple T event, this is the total event, okay? It has T let's say T1, T2, something like that. Okay. Capital T is an event. It is a mutually exclusive partitions. Okay. Capital T. So simple T's are the one particular, I mean, simple T's are the event inside that huge event or partitions. So if I need to take probability of, I don't know what probability of, let's say T given capital 2, sorry, 2. 2 is again an event, separate event. So we can write our Bayes theorem like this. Probability of, sorry for that, I cannot. Probability of event 2, okay, given this event T times probability of this event T. Okay, clear? Which means first event, whatever inside this in the first place. Okay, divide by summation of this part. Summation of this part. Summation I equals 1 to let's say n. Probability of 2 given T i's. I can say, I can write this capital T as well. Okay, because my giant event is capital T. Okay, or I can write simple T i's because I have i's times PT, not PT, PT i's. Okay. Okay, this is the way to just remember this. Okay, probability of, let me go back. See, probability of whatever they ask. Okay, it is a one particular partition. Okay, so capital A is the giant one. AIs are the, or let's say A has partitions, mutually exclusive partitions, one A1, A2, A3 up to AK. AJ mean one particular partition. Okay, so if I need to find probability of AJ given probability of given event B. Event B is a separate event, okay, on top of that or whatever, okay, but within that sample space. If I need to find that, you can simply apply first probability of the given part B. See, B given whatever they ask, this one. So see, so they just simply interchange, okay, times what they ask, probability of or individual probability of that particular A, divide by summation of numerator part. Okay, why numerator I goes from 1 to k? Because A has k values.
Professor?
Has k partitions. Yes.
Professor, is it possible if you could cover an example? Because
Oh,
I
yes,
just
yes.
started. Yeah,
And
I just started.
yes.
I just started the homework, and it's very hard to relate, to be honest.
Yes. Give me a second. Next slide, we have an example. Okay.
Okay, thank you.
So this is how it works. Summation. Bottom denominator. It has the total probability. Okay. Clear? Any question? Just try to remember this first. Okay. Otherwise, you don't know how to use this. Clear? Any questions? How we change this? Why? So I means we have a new denominator. We have to sum each and every A case. I mean A1, A2, K. But J mean particular particular event, only particular event. Okay, only one partition. It can be A10, A5, whatever. Okay. Okay. So in this case, in this case, this guy, what we need to find, this probability we call posterior probability. Those are the words came from Bayes ideas. Okay, so first this part we call the given part, probability of particular AJ given B we call posterior probability. Okay, and this individual probability for AJ we call prior probability. Prior probability. Okay, those are two words. Just try to remember that. Okay, so individual probability we call prior. The given probability for that AJ we call posterior probability. Okay, clear? Always yes, probability of B definitely greater than 0. I told you it is obvious because denominator we cannot have 0, so that it goes to undefined, nothing to do with that. Okay, so always PB greater than 0. Same here, summation greater than 0. Okay. Okay, if we have if we need to find AJ dash given B, probability of AJ dash given B, so that you can simply apply what 1 minus, do you remember? If we have P, let's say if we have PC and PC is given, so we need to find PC dash. So how do we do that? 1 minus PC, right? The same idea here. But remember that in conditional probabilities, if you need to find the dash, it should be new first part. I mean, it should be this guy. Okay, clear? It should be that guy. Otherwise, you cannot take 1 minus that. Okay, clear? Okay. See this AI. Sorry. This one. See. Okay. You cannot use for a given part. If you need to find AJ dash given, sorry, A probability of AJ given B dash, you cannot use 1 minus AJ given B. Okay, clear? It's only for this first guy. Okay, okay. You will need that idea later in these examples as well. Okay, let's check this one. This is very common example for to apply the Bayes theorem. It's talking about cancers. Sometimes people have cancers, but after they check, it gives okay, yes, positive. Okay, which means correct. They have cancer. Result says yes, it is positive. But sometimes they have cancers. Results say no. We call false negative, because we have, but result says no. Same thing happened. We don't have a cancer, but result says yes. So that we call false positive, because it is positive, but it is wrong. Okay. So that idea is in this example. They have so they suppose that 1 in 1,000 have a cancer, which means probability of having a cancer is 1 divided by 1,000, right? Probability of having a cancer is 1 over 1,000, which means 0.001. Okay. A test detect cancer has done following properties. Given that someone has a cancer, okay. Given that someone has a cancer and having positive results, we already know that person has a cancer. Results say yes, positive. So that probability is 0.997. It is actually a high probability. Okay, you can have a higher chance to get the correct results, something like that. Next part, given that someone doesn't have cancer and the probability of positive results, okay, false positive results is 0.001. Okay, so don't confuse with this 0.001 with 1 in 1,000 probability. Okay, it is separate one. This is separate probability. Okay, okay, clear? So if you have a question like this, first you need to mention what are the events. Okay. So I think they asked 2 questions. Okay, we can see that. So first you need to define what are the events. So C, event capital C, we mentioned here having a cancer, okay. Capital P mean positive. So P dash mean what? P dash mean negative. P is positive, P dash mean negative. Clear? So these are the events, okay. This capital P and nothing to do with that our probability P. Okay, those are different notations. Okay, so this is an event. Capital C is an event. Capital this P is an event, positive. So see that, see C having a cancer, C dash mean no cancer. Okay, so same here, P dash mean negative or not positive. Okay, actually if you write C and P, that's fine. So so I know that, okay, C dash mean this, P dash mean this. Okay. Okay, so what is the probability of having a cancer? Having a cancer? 1 in 1000, right? 1 in 1000 means 0.01 given. A given mean, we can find it. Okay. So probability of positive, probability of having positive results given have a cancer. Already know we have a cancer, and result says yes, you have a cancer. See, has a cancer and having positive results. Probability is 0.997. Clear? Okay. This is how we convert words to our notations. Okay. Or sentence to our notations. Then what is this? False positive. Result says you have a cancer, but given no cancer. I think next part, this one. See, see, someone doesn't have a cancer, but result says it is positive. So value is 0.001. Oh, sorry. Clear? Okay. So what is PC dash? Okay. What is PC? 0.001. So what is PC dash? 0.999. Okay. Clear? So these things you can figure it out using this. Okay. Here, so where is that? Here you cannot find simply probability of P given C by using 1 minus, okay, 1 minus P given C dash. You cannot find that. Okay, I told you, if it is like in the second place, you cannot apply that rule. Okay. Okay. First, we need to find probability that test given positive. So test given positive results and having a cancer. So having sorry. Okay, test given positive. Okay, test given positive having a cancer, which mean probability of having a cancer means C given positive P. Clear? Clear? Okay. So first write what they ask. First write down it using your notations. Then try to figure it out. Then just expand that using your equations. Then figure it out what are the terms I need. Then you can simply plug that values and do your calculations, get the answer. Okay. First write what they ask. So they ask a probability of, let me check the, find the probability that the test given positive, okay, given positive, always these two, given something, which means always after this line, okay. So given positive, having cancer, probability of having cancer given positive. So you need to find this. Okay. What are the partitions of C? I mean, what are the partitions? C and C dash. Why? Having a cancer or not having a cancer, right? Only two. So as we mentioned in AIs, we have only two, A1 and A2, something like that. Clear? Okay. But what we need? AJ, we need one, A1, something like that. Okay. So if I convert that into our previous notation, if you are confusing with that, previously we had A1, A2, A3 up to A1, I'm sorry for that, A2 up to AK. Okay, so we wanted to find probability of let's say another event we have B. So we wanted to find AJ, let's say A1 given B, something like that. Now we have C and C dash. Okay, and we have positive event called positive. So we need to find probability of having what? Having a, I don't remember the question. Anyway, C given P, right? Okay. This is like here we mention it AJ. Remember that? This is C mean one particular sub event from that event. Okay. Okay. So apply the Bayes theorem. This is going to be like probability of, just change them, probability of P given C times individual probability of C. Okay, divide by summation of, okay, I'll replace this one, this part. It should be summation, it should be summation of probability of P given C, I'll call I, okay. For a moment, I'll call it I, probability of PCI. Okay, here I mean C or C dash. Okay, C or C dash. That's why we have this part, two parts. This is for C and this is for C dash. We have only two. So sum is like this. Okay, now what you know? Yes, questions? No. Now check, this is the posterior. Okay, and this is the prior. Remember that? Okay. You need to find this posterior, which means probability of C given P. So you know this one. Let's check. Do we have these values? Probability of P given C. P given C. Yes, we have. Probability of C. We have that here, somewhere here. See this one. Okay. Do we have this same thing here? Okay. Do we have this one? Yes, we have this part. See, and probability of C dash as well. Okay, just plug the values and simplify it a little bit. You can use your calculators, you can get the answer. Okay, so probability of test given positive and having a cancer is 0.4995. Clear? Questions? Okay, let's move to the next part. It is a little bit difficult. Okay. So find the probability, let's say find the probability that the test given negative and results having cancer, and given positive results and having cancer. Having cancer means C. So what you need to find? Give me a second. Okay, test given negative and having cancer. So you need to find probability. Having cancer means C. Given negative, right? It's mentioned given negative, right? So given negative mean P dash. Clear? So you need to find this. Let me check this. Yes, CP dash. Probability of CP dash. I'm sorry, these lines, I don't know where they come from. So simply you can apply the Bayes rule. Okay, this we call Bayes rule. Probability of P given C, okay, times PC prior probability divide by summation of this part. Okay, here you know what is a summation. Summation mean we have only C and C dash. Oh, sorry. Here P dash. Sorry, I missed it because we have the dash here. I didn't see that. Okay, clear. So this is P dash. So summation mean you can expand that probability of P dash given C times PC. Yes, don't stop there. Plus probability of P dash given the other C, which is C dash. Okay, those are the partitions of C times individual probability PC dash. Okay, so see, first write down what you need to find. Then you can check each individual terms and find the values. Okay, okay, this is the prior, this is the posterior. In this case, we need to find this is the prior. Okay, okay. Now plug the values, but you have to first check, do we have these values? Okay, check this one. Probability of P dash given C. P dash given C, we don't have. But we have P given C. Probability of P, sorry, probability of P given C. Yes, we have that. Sorry. So we can find probability of P dash given C. How? By using 1 minus P dash, 1 minus P given C. Okay, because dash goes to the P. Clear? Dash goes to this guy. So don't confuse with this P event P and probability P. Okay, they have used the same notation. So sorry for that. That P is different one. Okay, then you can find that value. So you know this. What is PC? I think you can find last slide. It has PC value. See, you can find PC from here. We have PC here.
I have a question.
Yes.
So on that slide previous,
Previous one. Okay.
okay, so the PC dash equals 0.999.
Yes.
How do you figure that out? Just the 1 minus
Yes. 1 minus from this.
from that? Oh, okay. Yep.
Okay.
Thank you.
Okay. Then, okay, go back. Go to the denominator part. So yes, we have the same piece. So no problem with that. This part, do we have P dash given C dash? No. But again, you can apply 1 minus for that. If you apply 1 minus to this part, it's going to be like this. Probability of P dash given C dash equals to 1 minus probability of P given C dash. Okay. So this guy doesn't change. So you can change only the first guy. Okay. Clear? So that value you can simplify because probability of P given C dash is there in the last slide. Okay. So plug those values and get this. So you can find this. And also you could find this. It's in the last slide. Okay. Clear? Plug those values, simplify. First thing in this, thing you need to understand in this Bayesian type questions, they are a little bit tricky. Okay. Definitely they are a little bit tricky. Only thing you need to simplify is try to convert what they have mentioned in the words to proper notations. Okay. See, in this example, when you read the question, it's really difficult, but when you convert it into our notations, it is easy. Okay. So very easily you can go wrong with this kind of questions. So please pay your attention when you while you are solving this kind of problems. Okay. I think we have another example here as well. Okay. Clear this question? Okay, let's go to the next question. Check this one. Do we have? Homework. Did you guys can access the homework? Yes. Okay. If you have that question, please send me an email. Okay, I'll reply to you. Okay. Okay. I don't think so. I picked the easiest questions from that test bank, but okay, let's try to finish this one. I think this is the last example. No, we have another slide. Individual has three different email accounts. Three different email accounts. Most of her message in fact 70% come to account 1, 20% comes to account 20% come to account 2, and the rest of 10% comes to account 3. So from message in account 1, only 1 is spam. Account number 2, only 2% are spam. Account number 3, only 5% are spam. Okay, so what is the probability that the message come into account 2? Okay, come into account 2, given that message is a spam. Okay, so simply in words you need to find. So let's say probability of message in account number 2, given that message is a spam. Clear? This is what you need to find. So you can do it like this. So it is easy. You can, if you can convert this to a notation like they have mentioned here. So AI messages messages into account number. Let's say we have 3 accounts, 1, 2, 3. So that's why they have mentioned AIs. I mean 1, 2, 3. A1 mean message in account 1, A2 mean message in account 2, something like that. Okay. And B is the spam. Message is a spam. Okay. Now you can replace that using this notation. Message in account 2. So A2 given is spam B. Yeah. Yes.
Probably that's stand for the message in spam. Why don't we put a B1, B2, B3 because
No, there is no B1, B2, B3 because just spam. That's it, right? There is no spam 1, 2, 3. Spam, just that. Spam is general word, it is it, right? But we have 3 accounts. So you have to consider that they ask come into second account. So you have to simply go to second account only. Clear? But we have spam. Spam is general term. It can be like, I don't know. We cannot split spams, right? They haven't mentioned spam like DDoS or whatever what they call the distribute. There are so many spam types like I don't remember DOS attacks. So they haven't mentioned something like that. It come from through the websites or come to directly mail something. Okay, just spam. Yeah, it's like event capital B we use in last examples. Okay, just one event. But A, it has values. Account number 1, account number 2, account number 3. Clear? Yes.
Hello. I was having a question apart from this. Like I was asking, like the notes which we are taking currently in class. So can you upload it on the current slides, by which it will be easier for us to check the answers and then and like these the important points.
What do you mean by notes? I think I have uploaded the same notes which I'm using.
No, like the notes are same, but the points like the points which are you are writing with the pen.
Oh, I'm writing on the
So,
okay, okay.
so in second way, you are just simplifying the question for us. So once when we are trying this question by our own, so it will be easy.
Okay, I'll try to do
If it's
something.
possible,
Yes, yes,
then
I'll
only.
try to do that because to do that I have to save everything. I'll try it. Okay.
Oh,
I'll
thank you,
try.
sir. Thank you so much, sir.
Yeah, yeah. Okay. Any questions? Do you understand that? I mean, so you are asking why we don't have partitions, right? We don't have partition because we just consider it is spam or not, just spam. No, not spam. I mean, spam or not, no, just spam. Okay, just spam. Clear? Yeah. So don't confuse it that yes, you may have this kind of uh, this kind of confused stuff, but while you are solving problem, yeah, that will go away. Okay, believe me, that will go away. Okay, any questions up to this point? No. Let's try to find. So this is same thing what I mentioned. Okay, we need to find probability of A2 given B. First, write down what are the probabilities you already know, or simply you can find. So these are the things you already know. They have given this in the text, and also this. Okay, it's given in the text. Probability of B given A1, it is given, right? 10% or 10% or what? What is this one? Probability of B given A mean message is a spam given that account 1. Only one is spam, only one is spam. For account 1. See, this first sentence end from here, next one start from here of the message into account 1. Okay, only one are spam. Okay, so spam, yes, given account 1. Probability is 0.01 because it's 1%. Okay, so same as other two, you can find it. So you need to find this posterior probability A2, probability of A2 given B. So apply the Bayes theorem. It is this. You have three partitions like A1, A2, A3. That's why I start from 1 to 3. Okay. So once you expand it, it's like this. Numerator doesn't change, but denominator, it goes from 1 to 3. Here A1, middle part A2, last part A3. Okay. So plug the values and get the answer. Any questions? Feels like you're confused. Any questions? Okay. Clear? Okay. Believe me, in your mid exam, this is to, yeah, in your mid exam, I'll be giving, definitely I'll give you a Bayes question, question to apply the Bayes theorem. Okay, because it is something like a giant part in this chapter 2. Okay, so I can promise that. Don't worry, it's not that much hard, but try to understand this. I think you may have homeworks as well.